Good morning, everyone. Today we will discuss on the atmospheric circulation, or we may call it as wind circulation. Now, from our previous classes, we came to know that for surfacial movement or horizontal movement of atmosphere, it has to depend on many factors, mainly the external factors, but the most important factor is temperature, and it is the temperature due to which different areas of earth solution, and thereby temperature at different points of earth varies across latitude from places to places, and thereby they are formed some amount of pressure difference, due to which a gradient generates, and that leads to some kinds of horizontal movement of air from one point to another, that is from higher pressure point to lower pressure point, and that horizontal movement of air we called it as wind. Now, air generally found to move all around the world, and this global pattern of circulation of atmospheric gases or air is known as global atmospheric circulation. Air generally flows from high pressure areas to low pressure areas, and this generally happens due to the uneven heating across latitude, the unequal heating of the Earth's surface generates pressure difference, and due to which the horizontal movement of air occurs. Now, if we look at the insolation difference across Earth, we found that at different latitude, sunlight or incoming solar radiation fall at different angles. It is mostly fall directly or perpendicularly over the equatorial region. So, in the equatorial region, per square unit area receives maximum amount of insolation, and as we move higher latitudes from the equator, the incoming solar radiation falls in a angle, and thereby the per unit square area receives lesser and lesser amount of energy. So due to this, the temperature at different points over the earth's surface across latitude varies. Generally, it is found maximum at the equatorial region, and towards high latitudes, temperature gradually decreases. Now, due to this uh, temperature difference, a general circulation was found to occur, that is from the low pressure zone at the equator towards the high pressure zone at the pole, or you may say it otherwise, that is from the high pressure zone at the two poles towards the low pressure zone at the equator. So this broad circulation of air from the high pressure zone at two poles towards the low pressure zone at equator is mainly governed by the differential heating. But apart from temperature differences, there are some other factors which also affect this broad circulation of wind. So if we consider a non-rotating homogeneous earth, homogeneous means that there is no uh, difference or no contrast of land and water or mountains or grasslands over the earth's surface. So throughout the earth, entire earth, if we consider, is made up of a single uh, thing. The surfacial cover is made up of a single thing, that is homogeneous earth, and the earth is non-rotating. So now, due to differential heating, as I already told, the temperature is maximum in the equatorial region. So here forms a low pressure zone. The air generally moves vertically, goes up into the troposphere, and simultaneously the cold dense air from the high pressure zone of the poles that move as surface wind towards the equatorial low pressure zone. Similarly, the air which rises up in the equatorial region after going up into the atmosphere, gradually it cools down because it is now far away from the uh, heat source, that is the terrestrial su- surface. So gradually this above air cools down and it moves as the upper layer uh, towards the poles. So if earth is non-rotating and if earth is homogeneous, then we may found this kind of circulation of wind. So we found a broad circulation or broad convection cell uh, in both hemisphere. So basically it's a uh, one cell for both hemisphere. Now we know that earth is not a non-rotating body, rather earth is rotating. So due to the rotation of the earth, apart from this heating difference, the Coriolis effect act towards this circulation of wind. So again, if we consider that earth is homogeneous and in this case earth is rotating, so here again a single convection cell is found in both hemisphere, but due to the rotation of the earth, Coriolis effect is now came into the scenario, and thereby the movement, the superficial winds, they are found to be deflected to the right in the northern hemisphere, whereas they are found deflected to the left in the southern hemisphere. Now, apart from this um, single um, layer or single cell rotation earth model, it was found by George Hadley that in the equatorial region, the air rising up when it goes to the upper part of the atmosphere and gradually cools down and moves towards the upper air towards poles at about 30-degree latitude in both hemispheres, it becomes cool and dense, and then at 30-degree latitude in both hemispheres, it sinks or subside. So near the 30-degree north and south latitudes, there formed a high pressure region that is known as subtropical high in both hemispheres. Now this subsiding or this sinking air when reach the ground surface, it divided into two parts. One part moves more towards the polar region as surface wind, and another part moves towards the equatorial region as surface wind. Now, this equatorial region surface wind now forms a smaller shell from subpolar high to the equatorial low pressure zone, and this smaller shell confining from the equator to the subtropical high is known as Hadley cells. After this discovery of Hadley that there, apart from the broad convection cell model, there exists a small cell near the equatorial region, another scientist named as Ferrel, he found that a similar kind of shell also found to exist in near the polar region. In the polar region, there exists a polar high, that is a high pressure region, and this high pressure moves as surface wind towards the low latitudes. Now, and about 60-degree latitude in both hemisphere, this polar wind and the wind coming from subtropical high, they meet or they collide with each other near about 60-degree latitudes. So due to this collision, this wind now moves up. So this upward movement in the subpolar region towards the uh, or near the 60-degree latitude creates a low pressure area at about this latitude in both hemisphere. And after going up, this air again divided into two parts. One goes back to the higher latitudes towards pole, and on moves to the uh, equatorial region. So again, another sail was recognized by Ferrel near the polar region from the poles to 60-degree latitudes and then goes back. This convectional sail is named after the Ferrel, and it is known as, sorry, this convection cell, as it found to occur near the polar region, it is known as polar cell. And the subtropical cell, which is confined between the 30-degree latitudes to 60-degree latitudes of both hemisphere, is named after the scientist Ferrel, and it is known as Ferrel cell. So now, due to the combined effect of rotation of Earth, Coriolis effect, and different latitudinal condition over the Earth, globally, three broad circulation cells are found to occur near the equator. From equator to 30-degree latitude in both hemispheres, the Hadley cell. From 30-degree latitude to 60-degree latitude in both hemispheres, the Ferrel cell. And from 60-degree latitude to the poles in both hemispheres, the polar cell. Is generally found equatorward, and the flow in the upper part of the troposphere in this trade wind is towards poleward. So it's a convection cell, the Hadley cell. The surface wind is toward equatorward, and the upper wind is towards poleward. Now, in the northern hemisphere, the prevailing wind is found to move towards equatorward, and due to the Coriolis effect, it was found that the apparent direction of this trade wind is from northeast to southwest. So it is often named as northeast trade winds. Similarly, in the southern hemisphere, it is found that the apparent movement of this wind is from southeast to northwest. Now, these names are given depending on from which direction the wind is coming. So you can see in the northern hemisphere, the wind is coming from the northeast towards southwest. So from the direction of origin, the names were given. So that is why it is known as northeast trade winds. It is known as southeast trade winds. Next, after the trade wind belt, we found in the more higher latitudes the mid latitude westerlies. This belt of prevailing westerlies generally lies or generally found to occur between 30° to 60° latitude in each hemisphere. Here, the movement of air, basically the superficial movement of air, is found to occur towards poleward. Now, these winds, while moving into higher latitudes, are deflected to the right in the northern hemisphere, and in the southern hemisphere deflected to the left. So again, here you can see the wind is coming from southwest to northeast, the apparent movement path. For the southern hemisphere, the wind is coming from northwest to southeast. So as the wind is coming from west, that is why it is named as westerlies. The wind in this region is generally very dry. There are the moving cells of this region is not thermally driven, and it was found that these westerlies blow throughout the year, but mostly during winter times it was found that this blowing of surface wind in these westerlies are found to be stronger. Next type of wind movement is found in the polar condition. Now, one interesting thing happened in this uh, near about 60° latitudes, because it is the region in which the subtropical wind collide or meets with the cold, heavy polar winds. So often in this situation, the situation begins very much uh, terrific, very stressful. So lots of thunderstorms or lots of um, then fluctuating weather conditions are found to occur in this latitudinal condition, because two contrasting temperature wind collide with each other. So depending on the conditions, depending on the persistence of weather conditions in this region, in this subpolar low, in ancient times, sailors named these regions differently. They express or they name the regions as roaring 40s or furious 50s or screaming 60s for the high velocity winds found to occur at different latitudes like 40°, 50° and 60° in this subpolar low pressure zone. So this tremendous situation, although it's a dry condition, no such rainfall occurs, but these um, high velocity winds are found to occur in this region, and this is generally occurred due to the collision of this hot subtropical wind with the cold, dense polar winds. Now, in the polar region or close to the polar region, that is from 60° to the poles in both hemisphere, there another circulation cell exists, and that we call as polar shell. And here we found that the superficial wind is generally coming from the polar highs towards the 60° latitudes in both hemisphere, and Again, due to the Coriolis effect, these polar winds is deflected to the right, deflected to the east in the northern hemisphere, and in the southern hemisphere, it is deflected to the left, that is deflected to the west. Now again, as these surfacial polar winds are coming from the eastern side, so they are named as polar easterlies. So these are the broad wind circulation pattern found to occur due to the combined effect of temperature difference, pressure difference, and Coriolis effect over the Earth's surface. But one thing is that in this, whenever we are going to describe these kinds of wind movement pattern, generally we are basically considering a homogeneous earth condition, but we know that the earth's surface is not homogeneous. The distribution of land and sea, mountains, the grasslands, they are found to occur over the earth's surface, so that makes the earth's surface inhomogeneous. And not only that, the distribution of land, sea is not equal in both hemisphere. So apart from this global circulation of wind model, which is mainly driven by the temperature, pressure, and Coriolis effect, there are local variation due to the land ocean distribution, due to some restriction like mountain belts. So overall, the wind circulation over the earth is in this type, but there are local variations. Now, one interesting thing, that is the polar fronts. It basically forms when the subtropical winds of the Ferrel shell meets with the cold dense winds of polar shell at about 60-degree latitudes of both hemisphere, and due to the temperature difference, one type of wind, that is the warm wind, that goes above the dry cold polar wind, so there forms a front, and the weather condition is extremely variable in these regions. That is the regions of those roaring 40s, screaming 60s, furious 50s, and this condition is known as polar fronts, and it occurs in surfacial conditions. A similar type of condition like the polar front, basically this generates due to the collision of two different temperature wind. A similar type of condition was also found to occur aloft, that is up in the atmosphere close to the tropopause. When close to the tropopause, two different winds, one having higher temperature, one is warm and the other is cold, meet high in the atmosphere, there forms a narrow strip of high flow wind, and this wind is known as jet streams. So often it looks like a fast flowing river of air close to the tropopause. So jet streams are also formed due to the collision of two different temperature bearing winds, but it occurs close to the tropopause, upper in the atmosphere. Now jet streams may occur in the subtropical region, where the equatorial warm wind and the subtropical relatively cold wind meet with each other in this region, and jet stream may also form in this uh, polar region, close to the polar region, near about 60-degree latitudes, where the subtropical wind and the polar wind collides with each other above. If you look at a satellite picture, you can see this green colored portion is basically the subtropical warm wind, whereas this reddish orangish colored uh, wind is basically coming from the uh, polar region. Now when these two wind meets, you can get an idea about the flow. A narrow strip of high speed wind occur at the junction between these two different temperature winds, and this high velocity wind which is flowing from west to east, generally jet streams are found to flow from west to east, and this narrow strip of high velocity wind found aloft, found higher up in the atmosphere close to the tropopause, is known as jet stream. And jet stream occur in the junction of two different cells. It is occur both in the junction of Hadley cell and Ferrel cell, as well as it is occur in the junction of Ferrel cell and polar cell. Now, apart from this global wind circulation pattern, as I already told you that Earth is not homogeneous. So depending on the distribution of land and sea, depending on the distribution of land surfaces, different land surfaces, there are some local variations which we called as local wind. Now these local winds are also important for the weather and climatic condition of any area, or often it influences a large continental landmass. Now the first type of local wind we evidence is the land bridge, and type of winds are found to occur near the coastal areas where the continental landmass is in contact with a large oceanic body. What happened in this time that during daytime, due to the differential heating of land area and the ocean water, the land area heats faster than the water body. So as the land area warms more compared to this oceanic water, so the air or the atmosphere is also becomes warm in the daytime. So here occurs a low pressure zone and the winds over the land area goes up. Simultaneously, this vacant place over the land surface area is filled up by the relatively cold wind occurs over the seawater area. So there forms a convection shell. Air goes up to the um, atmosphere in the land area. That vacant area is filled by the wind coming from the sea. The warm air again goes up and gradually cools down and sinks over the sea area. So if you stand at the beach or if you stand at the coastal area during daytime, you find that there is a smooth movement of air from sea towards land. So this wind is known as sea breeze because the wind is coming over the uh, oceans or coming over the sea. The opposite thing happened during daytime. Due to the large heat capacity of water at night time, the ocean water still remains warm compared to the land area. The land area after the uh, sunset during night time readily emits or readily radiate its energy to the atmosphere and quickly cools down. So at night time, the land area or land surface becomes cooler, whereas due to the higher heat capacity of water, the ocean water still remains warm. So due to this, now a low pressure zone develops over the seawater and uprising of air happened over sea. Similarly, this vacant place is filled up from the wind coming from the land areas, and again a convection cell generates from um, ocean to upper air to the upper air of land, then sinking to the land, and this land from this portion it moves as surface wind towards the ocean water. So during night time, you if someone standing over the beach, he or she feel that the smooth breeze is going on from land area towards sea. Now as the surfacial wind coming from the land towards sea, so it is known as land breeze. Next is the monsoon wind. We are just after few days or after 1 or 2 months, we the people of India will evidence the season monsoon. Now this monsoon winds, basically it is a larger scale version of land and sea breeze. Land and sea breeze are for local terms. Monsoon winds is the larger scale version of these land and sea breeze. What happens that in this wind, in this type of circulation pattern, wind is blowing from sea onto the land in summer, and during winter the blow occurs from land onto the sea. And this kind of movement, that is a different movement pattern in the entire year, that is in different um, conditions, different um, times of the year, is found only to those places in which the landmass is very close to the sea. Now what happens in monsoon? In monsoonal time, that is during summer, the land area, the entire Indian continental landmass and the surrounding land masses, the Bangladesh, Burma, Pakistan, the landmass become extremely hot during summer. So there forms or there generates a low pressure zone. Now, due to the generation of low pressure zone, the air within this landmass goes up or up into the atmosphere. So to fill up the vacant place, the wind from the adjacent seas, from the Arabian Sea, from Bay of Bengal, that goes to fill up that vacant space. So you can see that a circulation was established from the adjacent sea, which is relatively cold, dense, that will blow towards the Indian subcontinental landmass. So here wind is moving from ocean to uh, the continental landmass. Now when this uh, wind, this ocean wind is encroaching towards landmass, it will take lots of water vapor, and in suitable condition it will pour rains in the land masses of or in the land areas of India, Bangladesh, Burma, in all these countries. Now, oppositely, during winter time, the Indian landmass or Indian subcontinental landmass cools down rapidly. But again, due to the large heat capacity, a the surrounding ocean water bodies, they are still warm. So now low pressure zone develops in the Arabian Sea, in the Bay of Bengal, and that low pressure zone winds is replaced by the cold dense wind coming from the Indian subcontinental landmass. So it was found in the ancient time, those uh, sailors which sail their ships for uh, transporting from Africa to India or other places, they found that in the Arabian Sea, in different seasons, the movement of wind is different. During summer, the movement is towards northeast, and during winter, the movement of wind is exactly opposite, that is towards southwest. So, from the Arabic term monsoon, the this type of seasonal variation of wind movement pattern is known as monsoon. Now, these monsoon winds are very important, particularly for the India and Southeastern Asian peoples, because depending on this summer monsoon, the subcontinental landmass of India and Southeast Asia, there occurs a lot of rainfall, and this rainfall or this rain is used or recharge the groundwater, and it is later used for drinking purpose and irrigation purpose. Next type of local winds is known as mountain and valley breezes. Wind movement is found to occur due to differential heating in the mountain walls and in the valleys. Now, during daytime, the sides or the mountain walls get maximum amount of sunlight, and that becomes readily warm compared to the low-lying valley areas. So the wind over the mountain wall, they becomes warm and rises up. So that mountain wall winds now replaced by the wind coming from the valley. So this creates a movement of wind from valley towards the mountain walls, that is towards the mountain top. This wind is known as valley breeze. Alternately, during night time, the mountain slopes or mountain walls cools down rapidly, but the valleys, they still remains warm. So due to the warm valleys during night time, the low pressure zone exists in the valley, so a general movement of wind found from the mountain slopes towards the valley. So as this wind is coming from mountain slopes towards valley, towards downhill, this bridge is known as mountain bridge. Next is the catabatic and anabatic wind. These are the stronger versions of mountain bridge and valley bridges, and this is mostly found to take place at higher elevations. The in the higher elevations, again during daytime, the wind movement is found to occur from valley to the mountain walls to the higher slopes. So that is known as anabatic wind, or often it is nicknamed as valley wind. And during daytime, it was found that the movement of wind is from the mountain tops or high hills towards the valleys, towards the lower altitudes. And this type of movement is known as catabatic wind. or it is nicknamed as mountain wind. Wind speed in catabatic and anaerobic type depends on the differences in air pressure. The next type is known as Chinook winds. The name is mainly given for the South American landmass wind patterns found near the Rocky Mountains. This type of wind movement is generally found when the wind coming from the sea areas is get a restriction in the western slope of it goes upward, and the western slope of Rocky Mountain, basically that is the facing side, windward side of the mountain, it faces the wind, and when it goes upward and pulls down, it receives a lot of rainfall. After rain, after goes upward, when all the rains occur in the western part of Rocky Mountains, when it cross the Rocky Mountains, the wind becomes dry. That is the opposite side, that in the eastern slope of Rocky Mountains, they evidence a dry wind, and this dry wind basically named as the Chinook wind. So in the leeward side of the or down stream side of this Chinook wind, that is the side which face a dry air and almost no rainfall was there, so that zone is known as rain shadow zone, and drier side can form often desert. So extremely dry situation is found in the continental part of Rocky Mountain. If you see the continental distribution of this American landmass, you can see that uh, the wind coming from the sea hits the Rocky Mountains of the western slope of Rocky Mountains. It is restricted, goes up, and lots of rainfalls occurs in these coastal areas. But after rainfall, when this dry air is able to cross this barrier, cross the Rocky Mountains, in the opposite side, in the landward side of the Rocky Mountain, there was almost no rainfall. So this zone is known as rain shadow zone, and the effect is known as rain shadow effect. So the eastern side of the Rocky Mountain becomes almost dry, and often some desertic conditions are found to occur. This dry wind which is blowing in the eastern slope of Rocky Mountain, that is known as Chinook wind. So thank you. This is a broad or very brief idea about the global wind circulation as well as the local variation of wind circulations or local wind movement. And please keep it in mind that any kind of wind movement is happened due to the pressure difference between two regions, and this pressure difference is mainly develops due to differential heating. Thank you.